See if I have any examples here. There's one. All right. Really silly one, but what it does is we set some limit, num, that is passed into this function. And we're going to count from 1 and keep iterating as long as x is less than num. Now there's a bug in it. I see a bug in it. If I wanted it to go one time, I would have passed in a 1 there, and then x is equal to 1, and then while x is less than num, well, 1 is not less than 1, so it would not go into the loop. So in this particular case, I should have either started the counter off at 0, or I should do that. But anyways, is this case true? It's like an if statement. It jumps over here, does that. We update. If we don't update the condition, then it's going to be an infinite loop. If this condition is false to begin with, it never executes, right? Just like when num was equal to 1 and I had that, right? 1 is not less than equal to 1. Looked good when I wrote it, but it wouldn't work. Wouldn't print it out. Did I make that mistake down here in my actual source code? Aha, see, I had it right here. I just did not have it right here. So this is your loop control variable, whatever you're looping on. If your condition does not change in the process of the loop, it's probably going to be an infinite loop. Now there's two ways around that. One is you can have a return statement somewhere in here, right? It can't loop if it returns. A return causes it to jump back into the main code or the calling code. Or you could have a break statement. A break statement is one where it executes the loop, but then break causes it to bail out, to abort out of the loop. And let's go ahead and demonstrate that one. So if you wish to play along. Are we on J, H-I-J, maybe? I can't tell.
J.
There, okay, good deal. All right. So, itty bitty simple loop, using a while loop. There's better ways. You would use a for loop for this. We're going to count from 1 to 10. Here's our loop control variable. While x is less than or equal to 10, print high, end quote, in parentheses, and x plus equals 1. Now I'm going to change the logic a little bit, and it's going to repeat itself just as many times. As a matter of fact, instead of printing high, let's print high comma x, just so that we can see the counter iterate. And we're going to see it print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to change that to a 0. And change that to a 9 because of reasons. I run it and it prints out 0 through 9, but that's still an iteration of 10. I'm going to go back here and make this, instead of less than or equal to 9, it's just going to be less than 10. And it's going to do the same thing. And it's going to print out 0 through 9, which is 10. 10 different items, right? But using 0-based indexing rather than 1. All right, why did I show it that way? Starting off at 0 and going less than or equal to 10, because that's how the range loop works. Backspace all the way back to the edge of the margin. For x in range 10, colon, print goodbye, end quote, comma, x. It's going to do the same thing. There we go. 0 through 9. 10 different options. Why did I make a big deal out of that? Because people always want to make this the uppermost number, right? If I wanted to count it from 1 to 10, I'm going to put a 10 there. And if you've taken a programming course in Python before, you know that you can start its counting at a specific point by prefixing the end limit with a starting point. This is inclusive. It includes 0. This is exclusive. It never reaches 10. Once it reaches 10, it's kicked out of the loop. So that's why it goes 0 to 9. So these loops are quite equivalent. You can also control how many you want it to skip. I want you to go up by 2's each time. I'm going to print 0, 2, 4, 6, 8. And again, it stops when it hits 10. Doesn't stop after it hits 10. It stops when it reaches 10. It no longer goes in here and executes it. Notice that the range statement does not require us to update the loop control variable because it is being updated automatically. And as a matter of fact, even if we reset the variable, don't type this because it's dumb. Even if we reset the loop control variable, that gets completely ignored. The loop control variable is under the total control of the for loop here. And that's a little bit different than it is in Java and C++ or whatever, where you can modify the loop control variable even if you're using a for loop. So I was talking about break statements and while loops. Break statements to get out of an infinite loop. What if you do this? While true. Or what if you do while x equals x, colon. X is always equal to x, right? Print OK, ... end quote, in parentheses. It's just going to do that forever. Infinite loop. So, input, wait. CH for choice is equal to input, parentheses, quote, is this fun, question mark, y or n, end quote, in parentheses. Then, if CH equals, quote, n, end quote, colon, break. Now I'm going to add a few comments because the structure is looking a little bit janky here. I'm going to add an end if and an end while. Those are not necessary. In languages that support curly braces for denoting your level of indentation, then it's a lot easier to read. So here we go. Is this fun? Yeah, sure. Is this fun? Yeah. Yeah, okay, no, now it's not. No. And it bails out. The break statement kicks it out of the loop. It goes to the first statement following the loop. And breaks work in both while and for loops. So we could have put a break up here as well. Like this. For x in range, starting at 1, counting up to 10, so I'm going to make that at 11. Got to go one past it. Print x. But then, for some reason, we don't like 7s. We want to stop here. If x equals 7, colon, break. And I just added a couple comments. So it's going to print out 1, 2, 3, 4, 5, 6, 7, and then when it hits 7, it's going to hit that statement, break kicks it out of the loop. No, it's not fun at all. Stop right there. Okay. And there it goes. Right. Print it out 1 through 7. It aborted the rest of the loop. That doesn't mean you have to put a break in every loop you write. Normally you don't. Normally your loop statement will handle it, right? Normally that's good enough, or that's good enough. However, there are times when using a break judiciously is not a bad idea at all. And one of those is when you're doing century-based loops. Enter a number, or Q to quit. You could use that Q to quit as a break condition, in which case you don't have to do what's known as a priming read. A priming read is when you do something like this. Input x. While x not equal to something, do something with x. And then input x. Right, like that. This is a priming read. It's a read that you execute before you go into the while loop. It gets repeated twice in the code. I personally hate that. Here's how I would do it. While true, input x. If x equals something, that killer value that's supposed to stop it, break, else do something with x. That avoids the priming read, but at the expense of having a little bit of extra logic in here, an if and an else logic. I prefer to write it that way just because I don't like having to duplicate, because our inputs usually consist of like 3 different statements, or at least a complicated statement. You have a print statement before that, you get your input, you convert it to a float, you may do some validation on it, and then and only then could you go into the while loop, and then you have to do all that stuff again. I'd rather have to do all that stuff again only once. You can also use a return statement instead of a break statement to accomplish the same thing, except return would kick it out of the function entirely. It wouldn't go down to the next statement after the for and keep running. It bails out completely at that point. We can't have a return at this point because we're not inside a function. But we could write a function that had a loop, and then we could stick a return in it and prove the point. I'm not going to bother with that. So in general, loops work on a loop control variable or a Boolean expression. You can use a break statement to stop execution of the loop. The program will jump to the first statement, first unindented statement. If the condition does not change, and there is no break, no possible breaks, you get an infinite loop. So we may as well demonstrate the return. I'm going to close my triple quotes, define test parentheses in parentheses colon. I'm going to make a loop that would go from 1 to 10, but then when it reaches 6, instead it's going to return. So print parentheses quote before end quote in parentheses for x in range. Starting at 1, I wanted it to get all the way up to 10, so I'm going to make that an 11. 1 comma 11 in parentheses colon. Print out x, parentheses in parentheses x. Don't back tab like I just did, that was a mistake. If x equals 6, colon, return. Now I'm going to add a few comments. End if, end for, print parentheses quote after, end quote in parentheses. And then lastly, totally unindented, I need to actually invoke the function. So test parentheses in parentheses. No, not fun at all, is it? Okay, so there we go. It printed out before, it counted out 1, 2, 6, but then it did not print out after. If I change this to a break, it would print after. But return is causing it to bail completely out of the function, to jump back. But break wouldn't kick it completely out of the function. Instead, it would come down here and print out after. And then, since it reaches the end of the function at that point, there's an imaginary return statement there when it hits the first unindented line. So if I change that to a break, we will see the after message. If it says return there, we won't. So are there times when you want to use return to bail out of a function early? Sure. If some error condition gets set up and it's something that cannot be resolved, if there's nothing that function can do to fix that error state, then the function may very well want to just bail out of it early, right? If we were supposed to open to a file and we're supposed to be writing to a file, but we can't even open the file, then we may as well return out early rather than trying to, continue to loop and have some stuff at the beginning, at the end here. We'll get much more into that kind of logic later when we're doing file I/O. But you can have multiple return statements out of a function. Generally, the advice, the general, hand on your shoulder, is to only put one return at the end of the function and to code the rest of it so that it doesn't do that. However, it's also not a bad idea to do all your error checking up front, and then if anything is going wrong, bail out of it, and then the rest of your code doesn't have to check for those errors. And then you have another final return at the end. Sticking a return way down in the guts of a loop is actually considered pretty poor programming. It would be better programming if I made that a break, and then I did the return at the bottom. Because if you're editing something that's got 500 lines of code, you may not notice that there was a return statement tucked in the bowels of the loop. Right? You're expecting to return only at the end of the function. So here's an example of what I call the priming read. We get our data. While the data is not equal to an empty space, we convert it to a number, we add it, and then we ask for it again. Right? And there we go. And that's not really too bad. That's a very short loop. Yeah, sure, there was a priming read, but the expense of correcting the priming read while using a while true instead is that you have to have that if-lit logic. If the number that they entered was an empty quote, then break. Oh boy. So summation. Not only do you have to have a loop control variable, but you have to have an accumulator. The accumulator is going to hold all the values that we're adding onto it. And this is just demonstrating two ways of doing it. One with the for loop and one with the while loop. Even if you kind of just cross your eyes, right, and go by sheer amount of text, you can see that the for loop is a cleaner way of implementing it. Now why is that? It's because you don't have to initialize your loop control variable there, and then have an expression, and then an update. All three of those things are handled in one statement, one syntax. So, if at all possible, I would encourage you to write for loops. My favorite trick, and I'm using that term sarcastically, is I'll get up here in front of y'all, and I'll write a great big loop, and I'll forget to update the loop control variable. And then maybe I didn't test it immediately, and I'll write another 100 lines of code, and then we'll run it, and I'll notice it's an infinite loop, and I have to tell everybody to go back up and fix it. That never happens if I'm using a for loop, because the increment, the update of the loop control variable happens automatically. The loop can be complicated to write correctly. It is possible to simplify its structure and improve readability, especially by indenting. They're probably going to tell me that this is a bad way to do it. This is just what I demonstrated, right? When I said you could use break to bail out of a loop to prevent duplication of the priming read. Enter a number or just enter to quit. If that data is empty because they just entered nothing, then we will bail out of the loop. Otherwise, we will convert it to a float and we will add it to our accumulator. So, within the body, the input datum, ooh, that's a fancy word, is received. It is then tested for the loop's termination condition, and the break statement will cause an early exit from the loop. This example modifies the input Okay, this is a very good point, actually. I want to spend some time typing this one in without just looking at a slide. You can use a while loop to force a user to enter good input. You loop until they give you some good input. What do I mean by that? Remember way up here where we did this, is this fun, Y or N? What if they typed in something other than Y or N? We might want to become insistent and make them type in a Y or an N, right? Or enter a number, but they type in a non-number. That kind of thing. We can use a while loop to force them to give us good input. Of course, if they close the program, then that's that. But so something like this. Number equals 0. I'm just going to declare a variable, and I'm going to stick a 0 in it. And then I'm going to have a input that says while number is less than or equal to 0, colon. We're going to ask them to enter a number greater than 0. Print, enter a non-negative number, end quote in parentheses. Then let's get our input. Number equals in float, parentheses, input, parentheses, and then 2 close parentheses. If they get it wrong, we want to tell them. If number is less, you know what, I guess 0 is a non-negative number. I'm going to change this to positive number. Enter a positive number. And if number is less than or equal to 0, it's not a positive number. So if number less than equals 0, colon, print, must be a positive number, in parentheses, end quote, in parentheses. Now I'm going to add a couple of comments. Hash end if, back tab all the way, hash end while. Do you have to do that in your code? No. And then I'm going to print what they entered. You entered end quote in parentheses. But I forgot to actually print the number out. Comma, number. All right, is this fun? No. Enter a positive number. I'm going to mess up. Must be a positive number. Enter a positive number. No, must be a positive. Okay, it finally worked, right? So we kind of clamp down on our loop control variable, and we only allow ourselves to leave the loop once they have entered something that is of a valid value. So this condition needs to be something that is not a valid value. Now, honestly, what I would probably do in this language to make it a little bit easier to read is I would remove that. Now I'm not going to even modify it. You can kind of imagine that you could accomplish the same thing with a break statement, right? Would look something like this. While true, input x, if x is a good value, break. Something like that, right? Else print an error message. That's how I like to write it. I think that that's a nice clean syntax for it. And honestly, if you have a break or a return here, you don't even need the else statement. You can get rid of the else and just back tab this and it would work just as well. Right? Because if you haven't broken out of the loop, there's only one thing else you can do. But sometimes it's nice to see the word else. Maybe it makes the code easier to read. Maybe it doesn't. Up to you. That kind of thing. Like that. So you can use a loop to require the user to enter valid data. What if they type in something that's just going to flat out blow up? I don't recall if I've demonstrated using the try keyword. Have I done try yet?
Yeah.
All right. Same kind of concept. You could stick try inside of a loop. So, while true, colon, try this. X equals float, parentheses, input, parentheses, quote, enter a number, in parentheses, excuse me, end quote, and then 2 closing parentheses. And then break. If we get that far, that means we have a valid number. If we don't get that far, it's because an exception occurred, an error occurred. They typed in something that was non-numeric. So we need to handle that. So back tab 1 to make it underneath the try, except, and if that happens, we're going to print an error message. That was not a number. Parentheses in parentheses. End while. Now, assuming no syntax errors, this would loop, but if we ever typed in any non-numeric value, it would, it would not let them. It would not crash, unlike the other times when we've done float. It would just simply ask them to do it again. All right. Enter a number. That's not a number. That was not a number. Enter a number. Okay, fine. It worked. Now our code is getting to the point where we're having to input multiple things every single time we test it. And that's somewhat annoying. Anybody have syntax errors that they would like my... Alrighty. I figured I'd gone too far. You can do the same thing with a Boolean variable to control the loop. You can have a variable set to false, and then when they finally give us a valid piece of data, you set it equal to true. That would allow us to get rid of using the break statement, which some people would see as an advantage. So that would look, and I'm not going to actually type it into the code. That would look something like this. OK is equal to false. It's not good, right? And then while not OK, or while OK is equal to false, then you get your input. If input is good, then you set OK equal to true. Otherwise, you print out an error message. Like that. That's how to do the same thing as we did with the break statement, except instead of doing this while true, instead we're looping based on a Boolean variable. Either works. I'm kind of impressed with this textbook for showing this method first, because most of them go to some, they jump through hoops to avoid using the break statement. So this is more of a practical programming book than a computer science programming book, and I appreciate that. Now if they would only fix all the errors in the PowerPoints. So programming languages usually have a resource for generating a random number. What are random numbers? It's like rolling a die, right? For drawing a card out of a deck. You don't know what's coming up next. There's no such thing as a true random number that a program can generate. What do I mean by that? It's math. It has to be some kind of math. So what it is it's a formula that it follows. And under certain circumstances, it would give the same sequence of so-called random numbers every single time you ran it. Now, the functions in Python are written so that the likelihood of that is pretty extraordinarily small. But typically what they have to do, the way that it works, is the second number is based on a permutation of the first number. And the third number is based on a permutation of the second. And the fourth is based on a permutation of the third. So it's just some kind of formula to where the last result is fed into it any new result is kicked out. And to make sure that it looks random, quite often the random function will so-called seed it with a value based on the number of milliseconds since midnight, right? Because you're not going to run this program at the exact same time every day. So it will always look like a different sequence of numbers. So that's called a pseudo-random number. Pseudo meaning it looks random, right? Just like if you have pseudo leather, it's not real leather, but it's close enough. Let's print out some random numbers. To do that, we're going to have to use import random. And I'm tired of having to answer all these questions, so I'm going to scroll back up to the top of the code and put our new code up at the top. Wrong. Since I started a triple quote, I better end my triple quote before I scroll away from it. So if you had that comment there, it's great and all, but make sure you have your triple quote there that I forgot to put. All right, so up here. In order to use random numbers, I have to import the random library. Let's just print out some random numbers. Print parentheses, I believe it's random.next. Or randint, okay. Come back. Random.randint parentheses 1 comma 6 parentheses close parentheses close parentheses, and then copy and paste that. I just want to see 6 or 7 random numbers generated in a row. All right, and it did it. It printed out some random looking numbers. 3, 4, 1, 5, 5, 6. If I run it again, it should do the same thing, but different numbers, right? 5, 5, 3, 6, 5, 5. Cool, right? We wouldn't get the same numbers, same sequence every time we roll a die. What if we're a Dungeons & Dragons or Pathfinder player? We don't like 6-sided dice, we like 20-sided dice. Icosahedrons. And there we go. So you can use that to simulate games, right? Monopoly, whatever. You roll a certain number of dice and you move that many things around the screen. Or Yahtzee, right? Something like that. I want to write a program that's going to add 2 numbers together. And if those 2 numbers are equal to the maximum that the dice can allow, like, 2 6-sided dice can hit a 12, it's going to end the loop at that point. Otherwise, it's going to count how many times it took us to roll that. So let's declare a variable, num sides equal to 6. And then I need a counter to keep track of how many rolls there have been. So rolls equals, we're going to start off as 0. Or shall we start it off at 1? I wish that I had done this differently. No, I think I'm going to go ahead and make it a 0. Alrighty. And then while true, colon, let's get our new roll. X is equal to random.randint parentheses num underscore sides. Now that's a lot of typing, so I'm just going to copy and replace it and make it y equals. And then I'm going to say z is equal to x plus y. And I better increment rolls. Rolls plus equals 1. Now I'm going to check. Is x plus y equal to the maximum value that we could roll, which is equal to like 2 times 6? find out. If z equals num underscore sides times 2, because we're rolling 2 dice, colon, print, quote, max, exclamation point, end quote, in parentheses, and then end if and end while. Something I don't like about this is it's not printing the number that we rolled. We should print the number, right? Maybe here, because we've just calculated z. So I'm going to go back up here and do print, parentheses, quote, we rolled a, end quote, comma, z, end parentheses. So I just added that line. I also wish that we were printing out our counter so that we would know what counter we were currently at. I'm going to delete this line. Sorry about changing my mind here. I deleted that last line, and underneath rolls, we're going to print this out with a slightly fancier statement. Print, parentheses, quote, roll %d equals %d. We're going to use placeholders in a formatted print statement. So then close our quote, and don't put a comma here like we usually do. Instead, put a %sign. And then after the %sign, there needs to be an open parentheses and 2 closed parentheses. And between the open and the closed, we're going to print the variables. Rolls, comma, z. We're going to find out how many times it took to print out to find a 12. Roll 2 6-sided dice, roll 2 6s, 2 boxcars. I'm going to comment all these print statements out because they make stuff look ugly, right? And I'm going to stick a return statement here because this is the only thing I want to see happen, right? I'm kind of short-circuiting the rest of the program. I could take it out and the rest of the program would run, but all right, that was a bad idea. Delete that return statement. Oh, come on. All right. How about just input, enter to continue. I'm just putting that there so it'll pause before it runs the rest of the program, and I can kill the program without seeing all the rest of that stuff. Aha! I forgot that random int requires both a lower bound and an upper bound. And this is unlike the range statement where the upper bound has to be 1 past where you want. This actually does need to be 1 comma because that's where we're starting. So I'm changing this line here, the randint call, to put a 1 comma in front of the num side. So change both of those. And don't add those hashes. Those are just to let you know what I needed to change. All right, clearly I have an error. I think I forgot to put a break, didn't I? There should have been a break right here. Because otherwise it's an infinite loop, right? While true, the condition never changes. There was no break or return for it to get out. So after print max, indented equal to print max, put your break there. So this is the line that I just added now. All right, took 19 rolls to roll a 12. Run it again. That's pretty extreme. It took 47 rolls to get a 12. 36 rolls. It's a bell curve. It took 8 terms that time. And what do I mean by bell curve? If we're talking about random possibilities, then say you have a 3-sided die, right? And there's only like 1, 2, or 3. So you could roll a 1 or a 1, you could roll a 1 or a 2, you could roll a 1 or a 3. You could roll a 2 or a 1, a 2 or a 2, a 2 or a 3. You could roll a 3 and a 1, a 3 and a 2, and a 3 and a 3. This is the only time that'll add up to 6. If we put what they add up to, that's a 2. And as a matter of fact, I'm going to write another grid. 2, and then a 1, 2 is a 3, and a 1, 3 is a 4, and a 2 and a 1 is a 3, a 2 and a 2 is a 4, a 2 and a 3 is a 5, and then lastly, 3 and a 1 is a 4, 3 and a 2 is a 5, and 3 and a 3 is a 6. So here's our little range of possibilities. Out of all those rolls, we can only roll a 2 once or a 6 once. And how many combinations are there? It's a 3x3 grid? 9. So, right, only 1 out of 9 times with our 3-sided die can we get a 2. And only 1 out of 9 times can we get out a 6. However, it's way easier to roll a 4, right? There's lots of different ways to roll a 4. So 3 out of 9 times, a whole 33% at a time, we can get the median. How about a 6-sided die? Maybe you know this. What's the most common pair to roll if you have 2 6-sided die? 7. Yep, exactly. The reason being 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, and 6. It's that diagonal that gets repeated the most often. And so that would be a 2, 5, or a 3, 4, or a 4, 3, right? 5, 2, and a 6, 1. All of those different things. And so we can only roll 1, 1 in one possible way. We can only roll 6, 6 in one possible way. It's a 6x6 grid. So 1 out of 36 times are we going to roll a pair of 1s. 1 out of 36 times are we going to roll 12. But 1, 2, 3, 4, 5, 6. 6 out of 36 times, we're going to get the average, or not the average, but the median value, which is that 7. So like the rules for craps, if you roll a 7, it's bad, I think. Kicks you out. I don't remember the rules for craps. It's arranged so that, right, you fail more easily than you think you're going to, unless you understand the probability involved. And we were kind of seeing those results, right? Sometimes it took a lot more than 36 tries to get it. Sometimes it took fewer. Had somewhere I wanted to go with that, and I'm not sure that I want to go there. It would be fun to actually implement the logic of a dice game like craps. If I don't remember them, I'm not gonna veer off and try to do it right now. That'll be a future one. But random numbers are fun. What do I mean by that? If you're going to test an algorithm, you want to add up 10,000 numbers and see if your method for adding them up is faster than anything else. Well, it's far better to generate those random numbers than to actually have to use it to enter them. Or make a guess-it game, right? I'm thinking of a number between 1 and 100. Please enter it, right? Or you have 2 characters standing there exchanging blows in a simulator, right? Well, 1... Yeah, you make it like die-based, like, an RPG, like a role-playing game. 1 swings his sword, he rolls, does he hit? 2 swings his sword, does he roll, does he hit? That kind of thing, right? Introduces a random element in it so that the program is not entirely predictable. Any game with randomly occurring monsters, or any games where, an attack only hits, lands some of the time. And you're playing your old Final Fantasy game and they swing and they miss, right? You know that there are random numbers being generated. Oh. Yeah, let's say that we had 20-siders. We wanted to roll 2 20-siders and we wanted to find out how long it took until we rolled 2 20s. Could take quite a while. I'm not going to bother trying to figure out the probability of it. I guess it's 1 over 20 times 20, which is 400. So we beat the odds there. And there's a possibility that my probability calculations are wrong, because it seems like we're hitting it faster than 1 out of 400 each time.
It took me 1,261.
Okay, yeah, that's encouraging. Oh, come on. We could write a program that would calculate the average number that it took to do this. I kind of feel like doing that. I kind of feel like making this. Nah, I don't want to go off in that direction. What I was thinking about doing is turning this into a function that would return the rolls count, and then you could call it repeatedly, calculating the total number of rolls it took to do it. Now, it really wouldn't take that much time to get it to work. But, on the other hand, we may as well polish off Chapter 3 if we can. So, the random module supports ways to do that. It has different functions. Randint isn't the only one, but it's certainly an easy way. You specify the lower range and the upper range, and it goes to town. And as a reminder, if you didn't want to prefix the word random there, you could instead do something like this. From random, import rand int, and then you could eliminate these things, right? It would use that function based on that library without doing it. Now I'm going to undelete it, but if you like, I'm going to undo those changes. But if you like the looks of that better, if you want to specify them, or even if you do from random import star, bring all the functions in like that, then you would not need to prefix them with the name of the library. Oh, there's our simple guessing game. Sometimes I have us do this one. Enter a smaller number. Enter a larger number. Okay, this is just creating a range. If I was going to make a guessing game, I would just make it pick a number between 1 and 100, like that, right? Just because that's kind of classic. I'm thinking of a number between 1 and 100. Of course, when we say enter your guess, we should tell them the range, right? Because otherwise they could be guessing 7,000 and -20 and stuff like that. But anyways, we generate a random number between 1 and 100. Then we ask them to enter a guess. If the guess is too small, we tell them. If the guess is too large, we tell them. So we use if, elif. Otherwise, it's just right. It wasn't too hot, it wasn't too cold, so it's just right. So congratulations, you got it. And we use a break. Errors to rule out during a testing while loop. An improperly initialized loop control variable. If your loop control variable is set incorrectly, it won't get into the loop to begin with. A failure to update that loop. In other words, your condition never reaches true, so it never bails out. Or the failure to test it correctly. So if it seems to hang, if your program is just sitting there thinking, then you can hit Control-C in the terminal window. That'll stop it. Now, I don't have an infinite loop going on right now, but I could put one pretty easily. I'm going to go in here and I'm going to wind up deleting this. But anyway, so if we do this, x equals 0 while x, or x equals 1 while x is less than 10 colon x equals x minus 1. Now that's a bad loop. Why? Because x starts off at 1, but then what's its next value?
0.
Yeah, and then its next value is -1 and -2. And so it's going to be less than 10 for an awfully long time. So when I run it, now what would I really do? Normally I just come and close the window. But you can also give it what's known as a keyboard interrupt, which is hitting Control-C. Like that. Bails out of it. At least you then preserve your shell if you needed to see your shell, right? If the intermediate results of your shell. Otherwise, I would have had to just close it and I would have lost that. I wonder if it would ever loop back around. In some languages, Once a variable gets too small, it suddenly leaps, it wraps around, kind of like if your spaceship wanders off one side of the screen and then it comes back on the other, kind of a wraparound. Integers can do the same thing. Usually that's at the value 2 billion. But I'm not going to let this run long enough to test that. Better get rid of that or else it's going to do the same thing every time. So if a loop must run at least one time, use a while true. If you've taken another programming language and if you're familiar with the idea of a do loop. Python does not have such a thing. I'm going to just scroll down to the very bottom and add that as a comment. Python does not have what's known as a post-test loop. The way that one of those works is something like this. Do this stuff while x is equal to 1. Something like that, right? Keep repeating this until x is no longer equal to 1. So blah, 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 do something there. So this part of the code always executes, no matter what. But it may stop immediately afterwards, right? If we set x equal to 10 here, it's going to come in here and it's going to do blah, blah. And then it's going to come in here and is 10 equal to 1? No, it's not. So it's going to bail out of the loop immediately. But it did always execute that code at least once. And that's the reason that some languages implement post-test loops, is if you have a loop where the code has to execute at least one time, you do that. Why do you have that language construct? Because otherwise, if you have something like this, while x is equal to 10, but you set x equal to, or while x equals 1, but you set x equal to an invalid value before you go in, then blah blah will never happen, right? Because this condition rules it out. This is a pretest loop. While is a pretest loop. For is a pretest loop. Do is a post-test loop. We don't have a post-test loop construct in this language for whatever reason that Mr. Python decided. So, to implement post-test logic in Python, you do while true. While true, do blah blah. And then if x is not equal to 1, break. Like that. That implements the same logic as this kind of Java or C looking stuff does up here. So to implement a post-test logic in Python, use while true and provide a break statement. This is a perfectly fine decision, by the way. There's absolutely nothing that you can implement with a do loop that cannot be mimicked while using a while loop. It can just make for a slightly cleaner syntax. But really, it only took a couple more statements, right? It took an if statement and a break there to implement the same logic. So control statements determine the order in which other statements are executed. Right? If something. Well, if that if isn't true, it doesn't do that something. So it controls the order in which statements are being executed. You have select statements, which are if something, do something, else do nothing. Or if something, do something, else do something else, right? And then you have loop statements. So you have select statements, you have loop statements, and then the third form of control statements, which they don't call a control statement, but I think of it as one because it changes the order of execution, are function calls. Right? If we have a function, it's changing the order in which these statements are executed. I think somewhere up here we had a DEF. Yeah, right? So, along with all of our whiles and our ifs and stuff, we had a DEF, which caused all that code to be skipped. But then we invoked it, it jumped back up, and it did it, and it ended it. So I consider that there are three forms of loop control statements. That there are selection, which are the if, that there are the loops, for and while, and then that there are function calls. Now, a lot of textbooks don't agree that a function call is a control statement, and so they only list the selections and the loops. So if the MindTap quiz asks you how many different kinds of, anyways, for loops, we know what a for loop is now. A for loop has a header and a body. Whoopsie, come back here. Like this. That's the header, and this is the body of it. And when you hit something that's indented to the same level of the for loop, it's after it. And it will only hit that statement after the for loop is done. Since we have a return statement instead, it'll never get there. So for loops can be used to implement a count-controlled loop, or they can iterate through a series of values. I need to watch the time because I want to give you some homework, but it looks like we're at the second, near the second to the last statement. May as well come back up to here, and we're going to declare a list that's got a couple of words in it. Maybe even up above import random, at the very top of the code. L for shortcut for list equals square braces. If you've done Python, if you've done Java or C, you're used to using curly braces to declare lists. I, end quote, comma, love, end quote, comma, Python. Almost typed Java. Well, I do love Java, but we're demonstrating Python. End quote, end square. And then for word in L colon, print parentheses word. And it's going to print out I love Python. One per line. So the for loop works not only on ranges, but it works on sequences. It works on lists. You can even embed the list directly in for word in, and then square brackets, and inside there, let's put some other words. I think, wait, no, I, end quote, comma, quote, am, end quote, comma, quote, awesome, exclamation point, end quote, like that. And then do the same thing. Oops, there was supposed to be a colon at the end of it because it's a for loop and I need to indent, and you always have to put a colon before you start indenting. Print parentheses word. So now it's going to print I love Python, and then it's going to print out I am awesome. This is the other syntax for a for loop. And then you can have for range statements, right, which do counting. So you can use for to iterate through a counter. Use for to iterate a counter. Or use for to iterate through a sequence, a list. We've talked about percent signs, formatting strings. Worth adding a comment to that effect. Print with percent does a formatted print, and this is rehash. Percent %d for ints, percent %s for strings, percent %f for floats. And here's our example. Print, parentheses, quote, my name is percent %s, end quote, comma, I'm going to put my name. You may as well put your name. Except you don't put the comma there. You do in every other language, not Python. You use a percent sign. Print. I am percent %d years old, and percent %f, and I'm going to actually use the word percent now, sorry, percent awesome, end quote. Now I'm going to skip to the next line, just because I'm running out of space. You don't have to. Your editing window's wider than mine. Percent, and then parentheses, how old am I? well, I'm old. I'm 98 years old. Comma. And how awesome am I? I am so dang cool. 101% awesome. And then one more closing parentheses to match that one. I'm going to move my percent down here. And really, I would just put it there and put the whole thing up there, right? That's what I'm expecting y'all to do. This is what your print statement should look like. Okay. So anyways, now I'm going to run it. We have some formatted print statements. We are almost happy. It's just that the percent, whoopsie, well, I might not want that many decimal places. Who remembers how to shorten the number of decimal places being displayed?
2D.
Yeah, percent 2D or percent dot 2D or percent dot 1D or percent dot 3D. I just want one decimal place in this case. Now, I always use percent 2 just because for money it makes sense, dollars and cents. All right, so percent dot 2F awesome. And again, there we go. We know what an if-else is. I don't even need to talk about it. We know what a break does now. Interrupts a loop, jumps to the first statement after the loop. Any for loop can be converted into a while loop. The other is not true. But you just pick the loop that makes sense. And the logic should be, do you have a counter? Use a for loop. Are you stepping through a series of values? Use a for loop. Otherwise, you're going to wind up using a for loop. You know what an infinite loop is, and you've seen randint. All right, guys, forgive me. See what we did last time for this. Last semester when we were using a different textbook. Otherwise, I'd be unleashing all these assignments on you. But it's a good idea to change them semester by semester because half of y'all probably know that there are websites where people collect assignments that instructors have given. So you Google up Rose and you find Donna Wilson and you get a list of all of her assignments. Now, I'm being overly optimistic. Obviously, that's not the case. They don't have every assignment for every instructor. See if this looks adequate. All right, here's a flow chart that I want you to implement. Start while true, and then tabbed over. Set total equals 0, count equal to 0, and average equal to 0. And then get the input, the max. Enter a number, or quit to stop. If max is equal to quit, then break. Otherwise, convert max to an int. Now this hash line just means that that's how the break is going to work. And then have a for loop for x in range 1 up to the max. Now that logic is bad, because if we type in a max equal to 10, then this is only going to count up to 9. Then we add that x to the total. What is it doing? It's just calculating a summation. You type in 10 and it's supposed to add up the numbers between 1 and 10. However, I goofed and it's only going to add up the numbers between 1 and 9. How would you fix that? You could make it max plus 1 there. Yeah. And then add 1 to the counter so that we can calculate an average. Honestly, it's stupid to calculate the average through every single loop, right? You should wait until the end. But that's how I did it, I guess, to make the logic cleaner. And then the factorial. The factorial is the exact same code, except you don't start the total off at 0. You start it off at 1. Why? Because the factorial is multiplying. 1 times 2 times 3 times 4. And if you start off at 0, 0 times 1 times 2, it's always going to be 0. So our total gets set to 0 rather than 1. And we're not calculating an average this time, so we don't need a counter or an average. Now let's go and actually look at the assignment itself. And if you can do the assignment without using the flowcharts, go for it. I've already demonstrated this stuff before. Write a script with a while loop that will print the total sum of all numbers from 1 to 100. Instead, I'm going to change it 1 to max, where the user provides max with input. Also determine the average in the print. And then the second time, the factorial. Prompt the user to input a number, calculate the factorial. 1 times 2 times 3 times 4 times 5. And then turn in. And if you make it mess up to where it only does 1 plus 2 plus 3 plus 4 when the user entered 5, well, I'm not going to come down on you because my flowchart's got the mistake, and honestly, I'm not going to. I guess I could put that as a comment down here, hence. I will fix the assignment. I won't be lazy. Right. I'll go back and add the +1 and all that. Here I did it. Yay, go me. So that's our homework assignment. I'll make a Dropbox for it. Any questions over this? It could be that this is going to be a little bit harder. On the other hand, I know for a fact that I have demonstrated summation loops, and I probably have demonstrated factorials. If not, you can certainly find factorial code on the internet. That doesn't mean that I want you to go and copy and paste the code that you find on the internet, but I'm just saying you can find the logic for a factorial online. So if you get stuck, you can ask me for help. Use the flowchart. You can Google up the algorithm. I don't mind if you Google up algorithms on the internet. Just don't copy and paste the code. We all good? I never asked that. Alrighty. Or not often enough. Let's make a Dropbox for ourselves. This is J. There is a Dropbox J now. Bigger in life. Go ahead and upload to it. If you're going to do so, please do. Prove you were here. Have a place to store your notes. And as always, I remind you, I don't care if your code actually works during the notes. But I do like everybody to have the satisfaction. So if you do want it to work, that's totally cool. I think I mentioned that one person writes all their notes on an iPad and then just uploads screenshots of that. Obviously, their code doesn't work. That's how they want to do it. That's cool.